You can solve these problems by drawing them on a graph and then using Pythagorean identities in some cases. And you can also solve them by using identities. Now we're going to specifically solve the problems using identities in this chapter. So I would have your identity sheet by your side. So when we apply these identities, you can see where they're coming from. It's going to be too hard to be flipping back and forth as we go through and solving them. So the first problem, I see that you're given the cotangent theta is 12/5, and the question is what's the tangent theta? I can see the tangent theta and cotangent theta are reciprocal identities, so I know the tangent theta is just 5/12. And that's all there is for that problem. Looking at number 5, the question is, what's the cosine alpha and the cosecant of alpha, given this? Now, it's telling me that I have a negative cotangent and a negative sine. The first thing that I want to do is determine what quadrant am I working in. Now, negative cotangent can be in this quadrant, or it can be, it can be in this quadrant or this quadrant by SATC. Again, these are the positive functions, the others are negative. And the sign is negative in this quadrant. So I'm talking about the fourth quadrant, which I'm going to remember when I finally get my answers. So the first thing that I would do is notice that the cotangent alpha is given. And if I can use this Pythagorean identity here, I can determine what the cosecant of alpha is. Thetas, alphas, you can substitute those in and still use the same identity. Therefore, I'm going to use this identity, substitute in, and solve for the cosecant of alpha in this particular case. You can use it, leave it as theta, or you can leave it as alpha. So this becomes 16/9 plus 9/9 equals this. And that means that square root of 15 over 3 is equal to the cosecant of theta plus or minus. Now, when you're looking at this, you go to this quadrant now, determine plus or minus, and therefore the sign is going to be negative. Therefore, this answer is going to be a negative square root of 15 over 3. Now, the cosine is also can be found in a couple different ways. The cotangent is the same thing as the cosine, and I'll just start with alphas again. Cosine alpha over sine alpha, which is the quotient rule. And I can actually substitute in for one to get the other. Now, sine of alpha is going to be -3 over 15. So this is going to be cosine alpha over -3 over square root of 15 equals -4/3. You can see these are starting to get quite challenging. Cosine alpha equals, let's see, -4 over 3 times, I'm going to multiply both sides by this, and then it's going to be a -3 over square root of 15. And as you cancel those out, it becomes 12 over square root of 15 positive, and that's what your cosine alpha is. Be very careful with subtleties on negative signs and cross multiplying. Looking at the last problem, again, these are quite challenging. So this means that the sine is positive and the cosine is negative. Sine positive is going to be here or here. Cosine negative is going to be here. We're talking about the second quadrant. Therefore, I know, first of all, the cosine of alpha is just the reciprocal, so that's going to equal a -1/4, and I'm done with that finally. Well, if I know the cosine and, let's see, I guess the secant and tangent have the Pythagorean identity that I can use. So I know that the tangent squared alpha plus 1 equals the secant squared alpha. And I want to do a substitution. So it's going to be tangent squared alpha plus 1 equals -4 squared. Tangent squared alpha equals 16 minus 1, or 15. Tangent alpha is equal to positive or -15. Now I look and see what quadrant. So I know that the tangent is going to be negative. Tangent alpha equals a -√15. A lot of subtleties on these problems, a lot of margin for error. So be careful all the way through the problem.